All right, so for problem number 13 off of the practice test says that there's an inclined plane with an angle of 23 degrees above the horizontal. What is the acceleration of a 500-gram block sliding down the inclined plane? Assume no friction. So first thing we need to do is draw the picture. So here is our inclined plane. The angle right here is 23 degrees. We're going to have a block. The block, oh, that's a horrible block. The block, perfectly drawn block. That has a mass of 500 grams. And it's sliding down. So now the other thing that we need to remember to do this problem is that we're going to have to consider the XY plane. So remember, it's easier if we make this the x-axis and we draw the y-axis perpendicular. And so what we need to really find is the acceleration. So the acceleration is going to go parallel to the x-axis. And we know that gravity is pulling this straight down to the center. So this force right here is mg. And then define, so to find this portion of that, it's just going to be and remember that when we say force has two meanings here. Force is the acceleration, right? And then that's also equal to mg. So if I said the mass times the acceleration and then mg, and I divided both sides by m, I would get a is equal to g. The problem is that over here, I have to tack on sine of theta because it's not, I need this portion of the vector. So I need to tack on sine of theta and sine of theta because that's how you get that portion of it. So then my acceleration of that block is going to be g times sine of theta, or 9.8 times sine of 23 degrees. That's the acceleration because there's an x and y component. When we orientate, when we change the orientation of the xy plane, that's how you calculate that. If we do the math on that, it's approximately 3.83 meters per second squared. Because this is mg and we need to separate the acceleration.